Hi, welcome back to Alien Space Education. Today we are my name's Andy from Space for All, and this is my podcast. I really hope you're enjoying it. Remember, the videos are being edited and they will be released soon on YouTube, so look out for them. I will still share the clips of what I'm doing and share them on Facebook and Instagram and everywhere else, as you've already seen. It's why you come here to listen to the full episode. So it's fantastic. I'd also like to apologise that I haven't recorded this sooner. My partner's been ill and I've had to look after her, which sounds terrible, but we're getting a treatment and she's going to get better, which means I will have more time to get back to recording these for you, and I really hope you enjoy them. So today we are focusing on one celestial body at a time, and today is the most familiar and fascinating planet of them all, Earth, also known as the third rock from the Sun. Our home planet, unique in many ways, from a complex ecosystem to diverse climates, its self-sustaining atmosphere. And we're going to take a deep dive into the structure of Earth, the dynamic processes, the incredible phenomenon that makes it a living planet for us to live on. It's fantastic. Whether you're an Earth scientist, enthusiast, or just curious about what makes our planet so special, this is the episode for you. So I really hope you enjoy it, and my work's paid off. So let's get straight into it. First of all, we need to know where the Earth is in the solar system. So, as I mentioned, it's the third rock from the Sun. Okay, the third planet. It's between Venus and Mars. It's part of the inner solar system, which includes the terrestrial planets. So you've got Mercury, Venus, Earth, and Mars. With Mercury is the closest, Venus, us, and then Mars, and we're the terrestrial planets. And we characterize these by our rocky composition. So we're a rock planet. We have rocky surfaces, as you know. The Earth is about 150 million kilometers to 93 million miles from the Sun, a distance we call as 1 astronomical unit, or AU. So when we're talking about other planets that are further away and we use an astronomical unit or an AU, we're measuring the distance from the Earth to the Sun, and there were times in that by however many that number is. So if we say it's 5 AU, we do 5 times 93. That's how far away it is. Okay, it's really important that you understand. That's where that reference comes from. The distance places the Earth within the Sun's habitable zone, often referred to as the Goldilocks zone. It's the perfect distance. It's not too hot. It's not too cold for liquid water to exist on the surface, and crucial for life as we know it. So we're looking at water composition. Okay, so if it's too hot, the water will evaporate. If it's too cold, the water will freeze. If either of those two things happen, we can't survive. Humans can't survive. We need liquid water, and that's the habitable zone, is where water can be liquid on the surface, H2O. That's what that means. That's why the Goldilocks zone is so crucial, and that is always around. Every sun is a habitable zone, and that's what we're looking for, is for the water to be in a liquid state. Okay. In terms of the size of the Earth is the largest of terrestrial planets. Its diameter is about 12,742 kilometers, or 7,918 miles. It's also the densest planet in the solar system, with an average density of 5.52 grams per cubic centimeter. That's really, really, really dense. It's really a lot of stuff crammed in there, really tight, and it makes it so tight. The density reflects the composition of the Earth's interior, so the iron core we have in there, which makes up of a metallic core, a rocky mantle, the crust that supports the vast diversity of life as we see today. So we're talking the whales, the crabs, the apes, the monkeys, the humans, the grasshoppers, the insects, the birds, you name it. We have a vast variety of life on Earth, and it is very, very different. But Earth's position in the solar system is just part of the story. It's just one part of it. There's a lot more to it. Our planet is also a complex system of interactions involving the sun and the moon. The moon affects us as well, and the other planets. For example, the Earth's axial tilt, so the Earth is slightly tilted 23.52 degrees, and it's responsible for changing seasons. So if it's always straight up, the seasons would be hot, cold, summer, winter. But because we tilt, we get 4 seasons because it changes. So that change is very changed. While the gravitational pull from the moon stabilizes the Earth's rotation and drives the tides, so the moon is affecting the seas, but also the sun has a gravitational pull to keep us in orbit. So the moon's pulling us away, the sun's pulling us in, so it's keeping us stable. But because of that, the water, more like a spinning top, so we spin out, we're a little bit wider at the middle than we are at the top, and as we rotate, the water stays still and the Earth moves, and that's why the tides move. And these crucial interactions maintain the balance of life that make Earth habitable. So there's a lot of different things that make Earth habitable, but there's just a few of them. Okay, moving on. The structure. Is that structure? Yes, the structure of Earth. Sorry, I'm checking my notes. The next, let's explore the structure of Earth, which is divided into several layers. So just like an onion, it has different layers, each with its own unique properties. These layers include the inner core, so we have a little inner core, then we have an outer core, we have a mantle, we have a crust, a thin crust, all of which play a role in shaping the planet's surface and driving its dynamic processes. If these things weren't going on underneath, the crust wouldn't have different surfaces. So at the center of the Earth lies the inner core. It's a solid sphere composed primarily of iron and nickel. If you ask your parents or teachers, they'll help explain what iron and nickel are. The inner core, has a radius of about 1,220 kilometers or 760 miles. So despite it being as hot as the surface of the sun, which is about 5,500 degrees, 9,932 Fahrenheit, it remains solid due to the immense pressure exerted on it by the overlaying layers. All these layers are crushing it down, keeping it solid, but it's still red hot as the sun. Next is the outer core. And this core is molten. So because this middle bit is so hot, the outer bit is going to be liquid, of course. And this is also iron and nickel. And it's about 2,300 kilometers or 1,430 miles thick. So it's quite thick. Twice the thickness of the inner core. The movement of the molten metal in the outer core generates the Earth's magnetic field. Now, the Earth's magnetic field is highly important. It protects us from the sun's solar radiation. So it is really, really important. It also helps animals migrate. So they use the magnetic field to know where to go. So this outer core is highly, highly important. Above the outer core lies the mantle. Now, this is the thickest layer of Earth. It extends about 2,900 kilometers to 1,800 miles from the outer core to the base of the crust. So we're talking the outer core here, the core here, and a crust on the surface here. So this is in the middle bit. Okay. The mantle is composed of a silicate material rich in iron and magnesium, while the lower mantle is relatively rigid. The upper silicate minerals, rich in iron and magnesium, mantle is more. So while the lower bit is rigid, the upper is more plastic. So it's very solid, but it moves. So this is moving very slowly, but this is moving quite fast. It's got a lot more elasticity in it. And the slow movement in it drives the process of the tectonic plates, which shape the surface of the movement of the larger plates on the crust. So the tectonic plates, you've heard about tectonic plates, they move and they're sitting on a bed of lava or magma, and it's all in this silicate, iron, magnesium rich mantle, and it's all moving. And sometimes the plates slide away, sometimes they crash into each other and dip or something like that, have earthquakes or volcanic eruptions. All these plates are moving that create these. So it sits on top of this. So the crust is the top layer, which is divided into two types: the oceanic crust and the continental crust. Now, the oceanic crust is thinner, only about 5 to 10 kilometers or 3 to 6 miles thick, and is mostly composed of basalt, a dense volcanic rock. Okay. In contrast, the continental crust is thicker, about 35 to 40 kilometers or 22 to 25 miles, composed primarily of a less dense granite. The crust is the layer of which we live on and supports the diverse ecosystem and geological features we see on Earth. So because we have an ocean crust and a living crust, so the ocean crust is right at the bottom of the sea. It's very, very thin. But we live on land, so it has to be very, very thick so we can live on it so we don't get too hot or too cold. It's really cool. We don't want to burn our feet. So we've talked about the crust, which then leads on to a more interesting thing of the plate tectonics and the dynamic Earth. Now, this is what helps make Earth so fascinating, is the dynamic nature driven by the process of the plate tectonics. The Earth's lithosphere, the rigid outer layer made up of the crust and the uppermost mantle, is broken into several large and small plates that float on a semi-fluid sphere beneath them. Okay, I'm sorry if I pronounce that wrong, so I'm going to spell it out so you have it. ASTHENOSPHERE. Sphere. My apologies. I'm dyslexic. Never mind. Now, these plates are constantly moving, albeit very slowly, at the rate of just a few centimeters per year. So they move a tiny amount. These interactions between these plates are responsible for many of the Earth's geological features and phenomena, including earthquakes, volcanic activity, and the formation of mountains. So when two tectonic plates push together, they go, and they can make mountains. Or, as you've seen in Africa, two tectonic plates are moving apart, and it's creating a new continent. As these will come apart, the water will flow in, and then we'll have a new country created. And it's really, really cool. It's all because of the movement of these tectonic plates. There are three main plate boundaries: divergent, convergent, and transform. Okay, divergent boundaries occur when two plates move apart from each other. This is common in mid-ocean ridges, where new oceanic crust is created and magma rises from the mantle to fill the gap. The process of the seafloor spreading at divergent boundaries, which drives the movement of the content over a geological timescale. So as these move apart, as the plates move apart, magma comes up, fills the gap, so they can't move back because the salt water and the sea cools it so quickly. It goes, I need rock, I can't move. Okay, we'll keep moving. So we get it, and that's what moves us. We have convergent boundaries occur when two plates move towards each other. When the oceanic plates collide, the denser oceanic plate is forced beneath the lighter one, so it goes down. And a process called subduction. And this can lead to the formation of volcanic mountain ranges, such as the Andes in South America, when two continental plates, so they can form towering mountains like the Himalayas. So even though these can happen underwater, at the bottom of the sea where it's very, very thin, they can also happen in land, and then we get big mountains and volcanoes. And that's how the Himalayas were formed and other things. And then we've got transform boundaries. Occur when two plates slide past each other next to each other. So rather than going head on, they're going next to each other. One's going left, one's going backwards, one's going forward. So they rub against each other. And they cause friction, which leads to earthquakes. A well-known example of transformation around it is the San Andreas Fault in California. Now, San Andreas fault line has a lot of active volcano, a lot of earthquakes happening all the time, but they're so small you barely feel them or anything like that, but they're always there. Plate tectonic is not just a geological process; it's also a critical process in Earth's ability to support life. The recycling of materials through subduction of volcanic activity helps regulate the planet's climate and creates conditions necessary for life. For example, the release of carbon dioxide from volcanoes plays a role in maintaining the greenhouse effects which keep the Earth warm enough to support life. So we need volcanoes to happen to keep us warm, because it releases so much carbon dioxide into the atmosphere, which is really, really good for us to live. So we need that process. And what happens is the trees feed on the carbon dioxide, produce oxygen for us to breathe. So this whole process is all linked together to help us survive. Okay, now let's look at the atmosphere and the climate. This is really good stuff, this is, isn't it? Okay. Another key atmosphere to Earth's uniqueness is its atmosphere, a complex layer of gases that surround the planet to support life. The atmosphere is composed of 78% hydrogen, 21% oxygen, and trace amount of other gases, including carbon dioxide, argon, and water vapor. This mixture of gases is crucial for life, providing the air to breathe, protecting us from harmful solar radiation and helping regulate the planet's temperature. So all these gases have to work together for us to live. And even though there's 21% oxygen, if we just breathed oxygen, we wouldn't survive. We need the other gases in order to do it, and nitrogen is crucial for that. So the atmosphere is divided into several layers, each with its own characteristics. The troposphere, the lowest layer, extended from the Earth's surface to about 8 to 15 kilometers or 5 to 9 miles an hour, depending on your latitude and where you are on the planet. This is where the weather occurs. It contains about 75% of the atmosphere's mass. So 75% is in the first 9 miles. Okay. The temperature in the troposphere decreases with altitude, leading to formation of clouds and precipitation. Clouds, precipitation, rain or snow, depending on the temperature. So depending on how it goes. Okay. Next is the stratosphere. This lies above the troposphere and extends to about 50 kilometers up or 31 miles above the surface. So we're going up about 31 miles above the surface in that layer. So between 9 miles and 31 miles is where we find the stratosphere. This layer contains the ozone layer, which absorbs and scatters ultraviolet radiation, or UV, you may have heard it, from the sun, protecting life on Earth. Now, you use sun cream to keep your skin from burning because of the ultraviolet radiation. The stratosphere diverts a lot of it, but doesn't divert all of it. So sun cream is really important for us. Okay, protecting from harmful effects. The stratosphere, the temperature increases with the altitude due to the absorption of ultraviolet radiation by the ozone. So the more the ozone absorbs, the hotter this layer gets, which means we get hotter as a result because it's trapping more heat in. So it's really good. Then we have the mesosphere. It's above the stratosphere, extending about 85 kilometers or 53 miles in this layer. The temperature decreases with altitude rather than increase, and this is where most meteorites burn up in the Earth's atmosphere. Hence, mesosphere, because meteorites come in and they go, they burn up, and then we don't get anything. Now, a lot of meteorites never reach the Earth's surface because they burn up in the atmosphere, and that is due to this final stage of burning them up. Then we have the thermosphere. This next layer is extended about 600 kilometers or 737 miles, and is characterized by a sharp increase in temperature to which we can reach about 2,500 degrees Celsius or 4,530 degrees Fahrenheit due to the absorption of high energy radiation. This layer is also where the auroras, a breathtaking light display near the Earth poles, occur. Now, the auroras are when solar radiation hits our poles and the magnetic field diverts it, but it happens in the thermosphere, so it happens well above us, keeping us very, 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 very safe. Then we have the exosphere. Angel. Okay. So the auroras are really, really beautiful and really bright, and they happen in the thermosphere. Next is the exosphere, the outermost layer, gradually fading into the vacuum of space. Exosphere. It extends from about 600 kilometers to about 10,000 kilometers, or 373 miles, to 6,214 miles. The exosphere is composed of very thin, sparse particles that can escape into space. This exosphere is where everything absorbs into space. So we want to stay out. If we can't breathe there because it's so thin, we get so thin. So it's there, it's protecting us. The Earth's climate, which is driven by the interactions between the atmosphere, oceans, the land, is another crucial aspect that makes the planet habitable. The climate influence is influenced by several factors, including the amount of solar energy received, the distribution of land and water, and the composition of the atmosphere. Now, these are all really, really important. So we need greenhouse effect to happen in order to have us, but also for things to relax, for us to survive. So it's all got to work together. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth, some of it is reflected back into space, while the rest is absorbed by the land, the oceans, warming the planet. When the Earth then radiates the energy back towards space as an infrared radiation. However, certain gases in the atmosphere known as greenhouse gases, such as carbon dioxide, methane, and water vapor, trap some of this infrared radiation, preventing it from escaping into space. This trapped heat warms the atmosphere, keeping the Earth's average temperature level so it can support life. So it has to work together. This greenhouse effect has to work for us. We have to look after it. We have to maintain that balance. However, us humans that live on the planet particularly have burning fossil fuels and deforestation have increased the concentration of greenhouse gases in the atmosphere, leading to global warming and climate change. These changes cause a shift in weather patterns, rising seas, and more frequent extreme weather events, posing significant challenges for the ecosystem and humans, society alike. What are we doing? We need to help the planet have a greenhouse effect, but not so much that we're destroying it by putting too many things into the atmosphere. We need to stop burning fossil fuels. We need to stop deforestation, but we need to maintain a healthy balance. And we need to get that balance back. And we have a lot of work to do there. And we need your help to do it. Ask your teachers about it, and they'll tell you. Okay. Any questions? Don't forget you can contact me. The next part is the hydrosphere and the water cycle. So there's really more to our planet. Wow. Water is essential for life. The Earth is the only planet with abundance of liquid water on its surface. The hydrosphere encompasses all of the Earth's water, including the oceans, rivers, lakes, glaciers, groundwater, water vapor in the atmosphere. It's all the water everywhere. Water covers about 71% of the Earth's surface, with a vast majority, about 97%, found in the oceans. The remaining 3% is fresh water, which is locked in ice caps, glaciers, and only a small fraction of Earth's water is accessible in rivers, lakes, and underground water. Yet this water that sustains terrestrial life. It's the water that helps us live a terrestrial life and human civilization, plus all the other animals and everything else. We all need water. So it's crucial. Okay, the water cycle or hydrological cycle is a continuous movement of water within the hydrosphere. The cycle is driven by solar energy, which involves several key phases. So first of all, we have evaporation. This process is which water from the ocean and the lakes and other bodies of water is heated up by the sun, transformed into water vapor. Plants also release water vapor through a process called transpiration. So they sweat. They, like humans, they release water as well. Then we have condensation. It occurs when water vapor in the atmosphere cools and condenses into liquid droplets, forming clouds. Now, condensation, you also see that if it gets too hot, you see condensation on the windows and things like that. Steam going up and you see water droplets. That's what clouds are. Precipitation happens when these droplets combine and fall to Earth as rain, snow, sleet, or hail, replenishing the water in the rivers, lakes, and oceans. So it's constantly going around. So precipitation is raining or snowing. Okay. Then you've got runoff. This is the movement of water, usually from precipitation over the land surface into the bodies of water. Some of this water infiltrates the ground, replenishing underground water supplies. So some of it soaks into the ground and goes down into the ground as well. And then you've got infiltration, this process by which the water seeps into the ground where it can be stored in aquifers and accommodation to flow in rivers and streams. So where do you think the water comes from? This is where, all due to this cycle of water. The water cycle is vital for regulating the Earth's climate, supporting the ecosystem, providing fresh water sources, also plays a key role in weather patterns and the disruption of heat across the planet, helping maintain conditions necessary for life. So if the seas get too hot, things like that, it evaporates. So it helps us keep us fair. Then we have the biosphere and life on Earth. And this is really, really long. We've got a lot to go. Another 3 sections. So we're getting there. Of all Earth's features, perhaps the most remarkable is the biosphere, a global sum of all the ecosystems where life exists. The biosphere extends from the deep within the Earth's crust to the upper reaches of the atmosphere, encompassing a diverse array of habitats and supports millions of species, including humans. So all life, all different species need a biosphere, and they all live on Earth. On Earth, this incredible, diverse, ranging from microscopic bacteria to towering redwood trees and massive blue whales. This diverse is supported by a planet's ability to sustain life in a wide range of environments, from the frozen tundras of the Antarctic to the lush rainforests of the Amazon. Excuse me. So there's different types of life. We're talking microscopic bacteria to the redwood trees, and it's all crucial. Without the biosphere and the diversity, we wouldn't be here. So we need this. The diversity of life also shapes the planet's geological process, such as the plate tectonics, which create a new habitat and drive evolution of species. For example, the separation of the continents has led to the development of unique species on different land masses, while volcanic activity has created new islands and that has served as laboratories for evolution, because animals have to adjust, or we have to adjust to our environment, just like animals do. So if there's suddenly an earthquake, tectonic plates, they separate. Well, some dogs in America won't be the same as they are in Europe or in the UK. They're all different because of the different places where they've come from and how they've evolved due to how the climate has changed. The biosphere is currently under threat from human activity, such as habitat destruction, pollution, and climate change. These activities are causing the extinction of species at an alarming rate and disrupting the ecosystems that have evolved over millions of years. Conservation efforts are crucial for preserving the biodiversity and biosphere, ensuring the continued survival of life on Earth, all life. Excuse me. So we, humans, are doing bad stuff to the planet. and we need to look after our planet. We need to do better. We can't keep destroying the trees, destroying the rainforests and things like that. We need to maintain it. We need to stop the destruction and start doing more care. Recycling is a key part in that. If you ask your teachers, there's other things we can do and other ways we are generating power and energy so we don't have to burn fossil fuels. There's lots of things we can do better and we need to do better, but it's a long, long road and it's not going to happen overnight. So you guys, my listeners, you guys are the people who are going to help energize and help us save our planet. Earth's future and human impact. As we reflect on Earth's past and present, it's important to consider the future of the planet. The role of humans will play in shaping it. Human activity has already had a profound impact on Earth's environment, and the choices we make today determine the future of our planet. One of the most pressing changes is climate change, which is driven by the increasing greenhouse gas from burning fossil fuels and deforestation and other activities. Climate change is leading to rising temperatures. Climate change is leading to rising temperatures, melting ice caps, rising sea levels, and more frequent and severe weather events. These changes are affecting the whole entire planet's ecosystem, food, water resources, and human health, and our livelihoods. Where do we get money from and everything like that? Because if it's bad weather, we can't travel for work or we can't work. So we need to think about all these different things. Just by not looking after our planet can affect us on our day-to-day life. If we don't look after the planet, we keep burning the fossil fuels and everything like that. Worst case scenario is we're going to melt all of it, all the ice caps, because the heat's going to get trapped in by the greenhouse effect. The sea levels will rise and just flood everywhere, and then we'll be a water world, and then we won't be able to grow crops. The animals will die out and the sea life will be great, but there won't be any dogs, there won't be any cats, there won't be any land animals because they'll all be underwater. So we need to balance things out and stop what we're doing. It's going to take a lot of work, but we can get there. In addition to climate change, human activity is also causing biodiversity loss, population, and a depletion of natural resources. These impacts are putting immense pressure on the Earth's ecosystem. Oh, God. No. Human activity is causing biodiversity, pollution, and the depletion of natural resources. These impacts are putting immense pressure on the Earth's ecosystem, threatening the services they provide, such as clean air, clean water, fertile soils, and the pollination of crops. So we can't pollinate the crops to make them grow. We don't have fertile soil for them to grow in. And if we don't have clean water, they're not going to grow. If we don't have clean air, the birds aren't going to fly and the bees aren't going to fly and pollinate. And oh my God, what are we doing? So humans, us, we've been fools and we need to correct it. But there is good news. Advanced technologies like renewable energies, sustaining practice offers solutions to these changes. By reducing our carbon footprint, conservation natural habitats, and promoting biodiversity, we can migrate the impact of climate change and protect the Earth's ecosystem for future generations. So we are developing new processes. We have started, but we need to keep going. And we need you guys to keep pushing and helping save the planet for other crucial. So it's also crucial for individuals, communities, and governments to work together to address these global issues. Education, like listening to my podcast, is a great start. This episode has been very educational. I hope you've learned a lot from it. Ask me more questions. Awareness, I shall teach us for more. Help us foster a sense of responsibility and stewardship for the planet. After all, Earth is not just a planet. It's our home. And it's the only home we have. If Earth dies, We don't. We're not going to survive. We need to look after our home. Just like you look after your room, you tidy up your messes and everything like that. You help clean up. And now we need everyone to help work together. Talk to your teachers about how you can help clean up your own little bit. And if everyone does a little bit together, just maybe we can do it. So, as we conclude our deep dive into Earth, it's clear that our planet is unique and dynamic. It's teeming with life and shaped by complex processes that evolved over billions of years. From the core to the crust, to the atmosphere to the oceans, every aspect of Earth is interconnected, creating conditions that allow Earth to flourish. By understanding the Earth's ecosystem and the impact of our actions is crucial to ensure a sustainable future. By studying our planet, we not only gain insight into forces that shape our world, but also learning how to protect it. Also, by doing this, we are looking at, as a species, humans, want to go to the moon and want to go to Mars and live on the moon and Mars. They want to build habitats. So by learning how to maintain and look after our planet, when we go over to the moon and Mars, we don't destroy them. We look after them. We use renewable sources so we don't drill down and destroy the Mars. We look at what can work for us better and do better. That's only become because we are looking at the stars. Keep studying, keep asking questions. Thank you for listening. Thank you for joining me for this Earth's Wondrous and the Celestial Spotlight. If you enjoyed this episode, please subscribe, rate, leave a review. Our next episode will be venturing into the mysteries of the gas giant starting with the mighty Jupiter, what lies beneath its swirling clouds, what is considered the king of the planets. Until then, stay curious, and remember, our planet is precious. Take care of it. Thank you. All the best.